Okay, so as discussed earlier, so please mention what is dimension, what is not dimension. So we have 7 columns. So in these 7 columns, mention which columns are dimensions and which columns are measures. So I'm just connecting to Tableau. So to connect to Tableau, so you can click on the Tableau icon or you can click on the cylinder icon over here. So I'm just clicking on this cylinder icon and clicking on this Microsoft Excel. So this is the file that I'm going to connect. So now Tableau will identify what is dimension and what is measure. So you can see the difference between the dimension and measure by seeing the color of that icon. So we have this as ABC. So Tableau is identifying it as a text and it is colored with blue color. So that is how it differs between a dimension and a measure. So blue color is nothing but a dimension. Blue in Tableau, blue is nothing but dimension. And green is measure. I mean, according to this context. So in this particular context, blue is dimension. So which is colored with blue. So this is a dimension. As we know, name, it's a descriptive part and it has only names and we cannot do any mathematical operations on these names. So this is a dimension. And salary, if you see, it is identifying it as a Is it audible now? Sorry, I was talking on mute. Okay, so yeah. So as we discussed earlier, please mention what is dimension and what is not dimension. So Tableau, when you connect to Tableau, Tableau will automatically identify what is dimension and measure. So here, if you see the ones which are in blue color, those are dimensions. The ones which are in green color, those are measures. So Tableau automatically identified this dimension and measure, and which has descriptive part, and this cannot be mathematically calculated. So that is why it is assigned a text ABC, and you can see the names. So there are multiple options here. So if it is a string meaning if it is a dimension, it will be assigning it string data type to that. And when you go to the salary, so this is a numbers and where we can do mathematical operations. So Tableau is identifying it as a whole number. So we do not have any decimals in this. So if you have decimals in the number, so it will automatically take number decimal as a data type. And when you have date in your data, so Tableau automatically figure it out as a date dimension. And you can see it colored as a blue color. And when you have time also entered in the data, so it will identify it as a date and time. And profit is also a number and you do not have any decimals. So it is identifying it as a whole number. And employee ID, if you see here, this looks like a number, but still Tableau understands by the name that I have assigned. So I have mentioned in the name employee ID. So based on the name of the header that I have given here, so Tableau is not considering this as a number, or Tableau is not considering it as a number which has to be mathematically calculated. Why? Because there is no point that we do any mathematical operation to this employee IDs. So we cannot add two different employee IDs. And if you observe here, it is being assigned with the blue color only. It still assigned with a number whole, but it is a dimension. So I will show you how dimension will be treated and how a measure will be treated in the Tableau. And there is a special configuration that is being assigned for the cities, postal codes, states, whichever is a geographical location. For geographical names, Tableau will automatically assign a globe symbol. So there is an advantage for that geographical locations where we can create map charts. So the places that I have given here, so Tableau will automatically show those places in the map chart. So these all places are registered, or automatically they have implemented in their algorithm. So they have mentioned each and every place in the algorithm. So if you write those names correctly, so Tableau will understand that it is a geolocation and what is the location of that particular geo location that we have specified. Even the postal codes, Tableau will understand. So that will be assigned with a globe symbol here. So if the names spellings are correct, so Tableau will automatically understand that it is a geolocation, and it will assign a geographical role for that. So Tableau also identified it as a city. And postal code, if you go here geographical role, it also identified it as a zip code. So now let's go to the worksheet. So this is the dimension versus measure Excel file that I have connected to. So can you repeat that? Postal code is, yeah, postal code is a dimension. Yes. All the place names, regions, all those which will have descriptive names will be considered as a dimension. Why? Because we cannot add two different postal codes. So there is no point we add these two postal codes. So that doesn't make any sense. So that is a dimension. So let's take postal code. So it will show you differently. So differently in the sense, distinct values you can see. So but when you drag salary, it is showing differently. Why? Because it is using an aggregation function. So it will not show you distinct values separately. So it will not show you distinct values. Why? Because it is a number. It has to use mathematical operations. So that is why it will be taking care of those IDs. So now let's see. So whenever I take any such column which is a number, so Tableau will automatically do the aggregation at an whole level. So what Tableau is doing is it will just do an aggregation of, so basic default aggregation which Tableau is assigned as sum, meaning it will add all those numbers. So sum of all these numbers, which is 1880. So that is what Tableau will show you automatically. So if you take profit, so what is the total profit? So it is basically taking all the profits. It is just doing the sum of all profits. But when you take dimension or any other descriptive number, so it will do, so let's say city if I take, so it will show you distinct cities. As postal code is a dimension, so you can see different distinct postal codes. So it will not do any aggregation because it is a dimension. Even if you take employee ID, so now let's take employee ID separately. So employee ID is also identified as a dimension. So we are not, even if it is looking like a number, Tableau is not adding these numbers. So Tableau will not add those numbers if it perfectly differentiates between a dimension and a measure. So basically, so yeah, so can you tell me which is dimension? So Vasu, can you tell me his name is a dimension or a measure? Okay, Sneha, can you tell me whether name is a dimension or a measure? Sadiq, can you tell me whether salary is a dimension or a measure? Yeah, perfect. Meenakshi, can you tell me whether date is a dimension or measure? Okay, so basically dimension, date is a dimension and profit is measure. And employee ID, it still looks like a number, but it is a dimension. Why? Because we cannot do any mathematical operation. City is a dimension. And postal code also looks like a number, but it is a dimension because we cannot do mathematical operation. So even Tableau will understand that. So as I mentioned earlier, so there is a specific operation which Tableau does for the geolocations. So for city, state, district, country, city, and postal code. So these are the geolocations which Tableau will understand, and based on this, Tableau will generate two auto-generated fields will be there, which is longitude and latitude. By which it will locate the particular location. So now let's go back to our file. So if I take city, so if I double click on this, so it will automatically create a location. So it is specifying the locations which I have mentioned. So I have entered Hyderabad and I have also entered Chennai, and there are two unknown places which Tableau is not identifying. So now let's see what are those places. So Bangalore is named as Bengaluru. So let's check Bengaluru. And Delhi, in Tableau, it is mentioned as New Delhi. So if the names are not matching according to Tableau, so it will not show those locations. So in Tableau, they have written the algorithm in such a way that Bangalore name is Bengaluru and Delhi is New Delhi. So now it will locate all 4 locations. So to show all these locations, so if you enter those names correctly without any spelling mistakes, so Tableau will automatically identify that. So if you write with some spelling mistakes, or if in the data, if it is not proper, then it will show an error. And later you can point it out and correct it to the right location. So this is for the city names. So you can just directly double click on that. So if you have geolocations, so you can just double click on that and it will locate those locations. And I can show the salary as well. Okay, so in this particular place, persons have more salary, and this is a person who has very less salary. So with that, we can identify. So even in the population, if you want to see, so population, so in which place the population is more and less, so all those can be colored like that. And now let's see. So postal code. So I'll enter the postal code. So if I double click on this postal code, so in postal code, there will not be any spelling mistakes. So it says it's basically a number, right? So there won't be any spelling mistakes. So it will directly show you without any mistakes. So I have taken only Telangana related postal codes. So that's why it is pointing only in Telangana. So this is how we can locate the locations by specifying the geolocation here. So that is how Tableau will identify what is dimension and what is measure. And also Tableau will automatically identify what is a geolocation as well. So based on the geolocation, we'll have a lot of capabilities, and date also. So in date also, we'll have a lot of options. So we'll discuss one by one. So I'll just show you what date capabilities are. So you can show here and you can aggregate. I mean, you can go drill down and you can do drilled up based on this. So there are a lot of options if you have date in date format. So we'll discuss that. So before going to that, let's go back to our slides. So that is what is dimensions and measures. So dimensions which cannot be aggregated, which is a descriptive part. So region, employee, location, and postal codes, all this will be dates will be considered as dimensions. And measures which can be calculated, which are numerical, and sales, profit, ratings, all this will be considered as measures, which can be measurable and which can be used for mathematical operations. So now let's go back to this difference between OLTP and OLAP. So this is also a fundamental concept where we can use it for data warehousing and databases. So OLTP and OLAP, online transaction processing and online analytical processing. So OLTP is basically the transaction that takes place in every places. So let's say if you go to any e-commerce websites, you go to any e-commerce website or superstore. So there they will make some entries in their systems. So let's say if you go to any superstore, so you made a purchase of 10 products. So they will make an entry on your name or on your number saying that this particular person has purchased these many products. So they will make an entry based on that, and they will store all those details. So all these are transactions. So every purchase that we make, so that will be as a transaction. And if e-commerce websites, in the sense, let's say if you go to Flipkart or Amazon, you made a purchase, so that will be an entry in their website. So if you cancel that entry, so that will be so they will edit that particular entry. So OLTP is the place where frequent inserts, updates, deletes takes place. So you keep on purchasing items. Hello, am I audible? Hello. Okay, yeah. So let's continue. Okay, so OLTP is the place where all the transactions happens place, and where most of the transactions takes place. Insert, edit, delete takes place. So this is the place where entries will happen. So examples like superstore and e-commerce website. So when you make any purchase on the e-commerce websites, if you buy something in the Flipkart, so there will be an entry. Or if you want to cancel that purchase this, so then also there will be an edit will be performed. So all these transactions will be happen, and these transactions will be stored in OLTP. So all these transactions will be stored in OLTP, and this is a temporary database. So data will be stored for few days or few weeks. So this is a temporary database. So after this thing, so from OLTP, so the data will be transmitted to the OLAP. So OLTP is the source for OLAP. So this is OLAP. So all the transactions will happen at OLTP level. So this is a temporary database. So this will not have huge data. Temporary database, it can store only few days or few weeks of data. Okay, let's take an example. Let's say it is storing a week of data. A week of data is being stored. So once that week is completed, let's say Sunday to Sunday. So Sunday to Saturday. So after Saturday, the data will be transmitted to the data which is there in OLTP will be completely erased. And after transferring to the OLAP, so the data, let's say it has 100 records in the OLTP. So those 100 records will be removed from OLTP and transferred to OLAP. So this will have historical information. So every week information will be stored in this OLTP. And this will have huge data. So why this will have huge data? Every week data is getting stored, coming from OLTP and getting stored here. But every time this particular OLTP will have only 1 week data. So as per our example, it will have every time it will have only 1 week data. So Sunday to Saturday. So every Saturday, the complete data what is there in that particular week will be transferred to the OLAP. So it will become with 0 records, and again it will start from the Sunday, whatever the transactions that are happening. So that will be stored in OLTP, and once that particular week is completed, all the data will be transferred to OLAP, and that will be stored in OLAP databases. And this will maintain the historical information. And as in the name, it mentions analytical processing. So this data will be used for analysis purpose. So when I say analysis purpose, so we will connect it to a system where we can generate visualizations, where we can understand how the data is being performed. So how many transactions are happening and what is the performance of that particular business that is happening. So later, this will be connected to a system where it will generate visualizations. So one of the tool is our Tableau. So they will connect to Tableau. So once the data is being stored in OLAP, so we'll just connect this particular OLAP to our system, a Tableau, and we generate the data. I mean, we generate the visualization. So this example that we are seeing here. So let's say sample superstore. So this is the weekly data which is came from OLTP to OLAP. So this is basically the OLAP data that we have here. So we are taking the data from the OLAP. So OLAP is the source for Tableau. OLAP is the source for Tableau. And OLTP is the source for OLAP. So you can see in this visualization as well. So OLAP is getting data from OLTP, and through OLAP we are making the visualizations. So let's see in the slide. So OLTP is the place where frequent inserts and deletes takes place. So maximum transactions wherever it takes place in the superstore or in the e-commerce websites. So they will maintain the databases for temporary purposes. So they will store the data weekly or daily on basis of their requirement. So they will store the data in that particular thing. And OLAP is the place where frequently data retrieval takes place. So as we discussed, every week or every month, so there will be a data retrieval takes place. So it will take the data from OLTP to OLAP. So here OLAP will retrieve the data from OLTP. And any user can interact with OLTP. So when I say any user can interact with OLTP, so as a person, I can log into Flipkart or any e-commerce website and I can make a purchase. Because of that purchase, an entry is being made by me. So I can interact with OLTP. So because of my purchase, an entry will be made in OLTP. So any user can interact with that. So if you go and purchase in the superstore as well, so because of you, there will be some entries will be made in their system. Even if you go to the ATM machines as well. So if you do a transaction, if you withdraw some money, so there will be a transaction that will happen, or there will be a record that will be entered in this particular system. And when you go to the OLAP, who are the users for this? Only topmost users, CEOs and topmost executives, and you can say business analysts and all will access. So let's say if I prepare any data, I mean, I'm using this particular data and I'm preparing the visualizations out of it. And I will use this to show it to the business owners. I will show it to the CEO of that particular superstore, or I will show it to the managers, site managers, and I will let them know how that particular site is performing, how that particular superstore is performing. So I'll let them know, and that they will take actions on based on the reports that I provide. So all the users are not the customers for or users for this particular OLAP. Only the topmost executives are the users for this OLAP. And any user interface is a source for OLTP. So even if your mobile is also a user interface, so you can log into that and you can make an entry. And all the OLTPs are source for the OLAP. So basically we are taking the data from OLAP itself. So OLTP itself. So for OLAP, OLTP is the source. So without OLTP, we don't have any data coming from anywhere. So OLTP is the source to OLTP. And source for OLTP is the transactions that we make. So from where the transactions are coming, basically from e-commerce website, ATM machines, superstores, etc. So for OLTP, this is the source. Yeah. And OLTPs are mainly used for the business purpose and mainly used to analyze the business. For OLAP, we analyze the business. Basically, we create some visualizations and we'll understand how the business is performing. And OLTPs will contain very less number of data. Why? Because it will store only that particular week or that particular month or that particular day data. So after that particular week is completed, the data will be transferred to the OLAP. So it will not have the historical information. Let's say if you have transferred this week's information to OLAP, and when you go to the next week, you cannot see the previous week data in OLTP. But in case of OLAP, it will store all the weeks of information in OLAP. So this will be having the historical information. So that is the difference between OLTP and OLAP. So now let's move on to the next slide. So with that, we have completed the session 1 slides. So now let's go to the session 2. So meanwhile, if you have any questions, you can type in the chat. I'll just answer those questions. Okay. So in this session, we are going to see how to connect to basic data and regarding tabs and icons in Tableau and what chart is right for you. And so I'm going to explain few of the charts. So change over time, correlation and magnitude. So now let's discuss what is the use of the tabs and icons in Tableau. So now let's start from the beginning. So let me open Tableau again. And if you need any help in the license, so you can ping me, or I'll just let you know how to install and activate Tableau license. So I'll just share that video with you in the group so that you can install and start practicing. Okay, so this is basically the Tableau interface that you see when you open it. So this is a welcome window. And here are the data sources which are provided by the Tableau. And let's see. So if you click on this Tableau icon, it will take you inside of the workspace. So this is what is the workspace. And when you click on it again, you can see the welcome screen again. And these are the some of the how to get started. So they will give you some basic information of Tableau, how to get started and all. And these are all the resources. And the below ones that you see here, these are the sample dashboards which are already built in Tableau. So if you want to go through those dashboards which are already built, so you can use these Superstore regional world indicators. Yeah, actually, am I audible? Your voice is not audible actually. 1 second. You can type in your question in the chat. I'm not able to hear anybody's voice. Am I audible? Okay, let's continue. Let's see. So Meenakshi, you can type in your question. Okay, so basically these are the sample data sources that you can connect to. So if you want to go inside the dashboard, so if you connect to any Microsoft Excel, it will just show you. So let's me connect to. Okay, so let's connect to this thing. So region and country and name, sales and date. So Tableau is automatically identifying what is date and what is number and all. So let's start. So these are the icons that you see here. So this is to create new worksheet, and this is to create a new dashboard, and this is to create a new story. So if you click on this new worksheet where you can create the visualizations, where you can drag and drop the columns and everything. So there are three things. So new worksheet, new dashboard, and new storyboard. So all this can be created in the below by using these below icons. So new worksheet is to where you can drag and drop columns. Where you can create charts. So this we have seen in the earlier session where we have dropped and we have created the worksheets. Let's say if I double click on this country, it will show a map chart where it will show you the location of the particular maps. And if I double click on sales, I can see in which location the sales is more and in which location the sales is less. You can see in China, I have the more sales and compared to Cambodia, and India is very less compared to, it is almost same. So Cambodia and India is same. So you can see the same size of the circle. Or if you put it in the color marks card, it will also show with the intensity of the color as well. So we'll see how this works. So basically, these are the icons to create worksheet and dashboard and storyboard. So dashboard is a combination of worksheets. It is a combination of worksheets. So where you will put all the worksheets at one place. So let's say if I have created a bar chart, and the map chart, and also if I have created entry sales, a bubble chart. So if I want to place all these worksheets into one place, so I'll use dashboard. So I'll place all these worksheets at one place. So like this, I can place all the worksheets into one place. So this is to create a new dashboard basically. And storyboard is something where you want to explain it like a story. So to create, this is to create a storyboard. And it is a combination of worksheets and dashboards. Worksheets and dashboards. And another way of representing data together. So here we can place in the dashboard, we can place our worksheet and we can explain how the data is performing across the regions and how the data is performing across the names and different places. So this is how we can analyze. So we can show all the worksheets together and we can analyze different dimensions. And storyboard is something where you can put something here and explain some story about this. Let's say these are the this is a bar chart which explains how the sales is performing. So like this, you can give some story about it, and you can keep a blank. So it will add one more place where you can add one more worksheet, and here you can explain how the regions are performing. So all this you can explain here. So this is like a slide in the PPT. So where you can go slide by slide. So in Tableau also you can go slide by slide. And when you can click on one more blank here. So like this you can keep many blanks. So here you can also insert dashboard. So the entire dashboard you can keep. So you can mention this gives information about info about region and names performance. So like this, you can create a story for your data and explain your story. So if people walk through like this, and they will understand what this particular worksheet is about. So they will understand by seeing the text on the top, and they can go click on this icon and they can see, go to the next. They can travel from one worksheet to other worksheet by just clicking on that. But in dashboard, we don't have that option. We can just see all the worksheets at one place. You can't just click, and you can't see what are the details of that particular worksheet. But in story, we can explain what that particular worksheet is talks about. So that is what these three icons are. And now let's discuss the above icons one by one. So this is what is Tableau icon, where you can go to the Windows screen. And this is undo and redo. So let's say if you drag anything and if you want to go one step back, so you can just click on this and you can go undo and like this. And this is to save the workbook. So if you want to save this workbook, so there will be two formats, TWB and TWBX. So I'm just saving with TWB. And I will tell you about these extensions as well. So we have a separate session for that. And this is to save, and this is to connect to different data sources. So these are the list of data sources that you can connect to, and these are the files that you can connect to. And these are the sample data sources which are provided by Tableau. So if you don't have any data handy, so you can directly use some sample superstore data or world indicators data, where you can try to enhance your skills. So this is to connect to, and this is to stop taking updates from the database. Start or stop. So this doesn't have anything, or it is better you keep it like this only. So if you stop the updates from the data, so it won't take any updates from the backend. And this is to add new worksheet. So the same option which is given below, so we also given on the top. So the new worksheet, new dashboard, and new storyboard, you can create here as well. So new worksheet, new dashboard, new storyboard. There's the same option which is here, shown here. And this is to duplicate the worksheet. Let's say I have created this worksheet with a lot of columns in it. And if I want to do a duplicate, so there is an option where you can just click on this and you can do a duplicate. So now you can see sheet duplicate is made. And if you want to remove all the fields, so I have so many fields here: country, sum of sales, latitude and longitude. I want to make this worksheet empty. So this is to remove or to clear the worksheet. So within a click, all the 4 fields will be removed from the worksheet. So I have removed it. So if I want to go back one step, so it will be coming back. So this is to remove all fields, clear sheet. And now I'll take name. And so basically these are row shelf and column shelf. So whatever I put in rows shelf will be coming in the rows. So let's say name, I have put it in rows. So I can see names in row level. So if I put it in columns, so I can see my names in columns. So if however you want to represent, so based on your requirement, you can make use of this name row shelf and column shelf. So now let's put this in. So I want to see names in rows. So, and I also want to see sales. And instead of, okay, I'll just put a bar chart. So to show a bar chart, Tableau is automatically taking name in the row shelf. So you can see names in the rows and sum of sales in the columns. So you can see sum of sales values are coming in the column level. So vertically it is coming. So horizontally, if you want to see, you can put the values or the dimensions or the measures in row shelf if you want to see the data horizontally. And if you want to see vertically, So you can put the measures or dimensions in the row wise. And if you want to flip it, so you can use swap rows and columns. So with that, you can flip it. So whatever is there in rows will be shifted to columns, and whatever is there in columns will be shifted to rows. So as we have crossed the time, so we'll just continue with the other icons tomorrow, and we'll also continue how to create charts in Tableau and what is change over time, and what is scatter plot and all, and how to create. I will explain step by step on how to create these charts and all. So we'll discuss that tomorrow. So what to create outliers, so you can use a box whisker plot. So I'll just so there is a box whisker plot in Tableau. So let's say if you have taken names or sales, so just use this box and whisker plots. So it will show you the outliers. So when I say outliers, so if you have data, let's say movies. So these are some of the movies, let's say. And ratings. So most of the movies are having ratings in the range of 9, 8. And yeah, so I have movies ratings in the range of 9 and 8. All of a sudden, I have some rating as 2 and 1. So this is an outlier to me. So to show outliers, what I will do is, I'll just save this file. So I'll just connect this Excel file. So it is best to use box and whisker plot to show the outliers. So let's say if I click on this, so you can see the outliers are D2. So you can, it is directly identifying which are the outliers. So and the movies which are in this range, yeah, so those are not unique. Yeah, so these two are actually the outliers. So any other questions? Okay, then thank you all for joining. We'll continue tomorrow.